My name is Vengatramani. This is my first education video. In this video, I want to just give some idea about nuclear physics, including atomic structure, radioactivity for class 10 students. Before entering into the topic, first you should recollect what we studied in the lower classes about the atomic structure. Atoms have a nucleus and electrons around the nucleus in different shells. If you have good grasp of periodic table, it is easy to learn atomic configuration. Atomic numbers are serially given for elements. It is represented by capital A alphabet. Atomic mass also is given with digital point accuracy in the periodic table. Atomic mass is represented by capital Z. Rows denote shells, column denotes valency electrons in the outer orbit in periodic table. This is pictorial representation of helium atom. Protons and neutrons in the nucleus together is called nucleons. What are photons and ionization? Photons. If an atom is given some energy by heating, electrons in the inner shell get excited and jump to outer shell. Very soon afterwards, getting cooled, the electrons return to their original orbit or shell. At the time it emits electromagnetic radiation called photon rays. Thus, energy in the form of heat given by us from outside gives radiation out in the form of rays, photon rays, by the atom when cooling. So photons may be infrared rays, ultraviolet rays, or X-rays. Ionization by heating. By giving further energy, electrons in the outer shell escape from atoms completely into the outer space. So atom become ion as electron count decreased in shell. This sufficient energy to eject electron is called ionization energy. Ionization by alpha rays. Another method of ionization is using alpha rays. We know that alpha rays having 2+ charges. So it has got good ability to take away, attract electrons from atom and take away electrons, thus causing ionization to the atom concerned. Then ionization, what is the definition? Ionization is making neutral atoms into positive ions by adding protons or removing electrons. In the same way, ionization is making neutral atoms into negative ions by adding electrons or removing protons. Just observe the picture, you will understand this. Isotopes, part 1. The atoms of same element with that same atomic number but different atomic mass are called isotopes. We know atomic number is coming serially in periodic table, and here we follow atomic mass on top. It is called A. Atomic mass is A, capital A. Atomic number is Z, capital Z, as per Cambridge books. Only any changes affecting the electron in an element, it will affect chemical properties of element. But in isotopes, chemical properties will be same in isotopes as electrons are same in all isotopes as atomic number is same. For example, hydrogen exists in 3 isotope forms. One is prosium, second is deuterium, and third is tritium. Conditions for isotopes are all should be same element, example hydrogen. All should have same atomic number. So atomic number for hydrogen group is 1. All should have different atomic mass. Atomic mass of hydrogen is 1, deuterium is 2, and tritium is 3. Isotopes, part 2. Hydrogen isotopes, as we know, it is of 3 types: protium, deuterium, and tritium. In the same way, carbon also is having 3 isotopes: carbon 12, carbon 13, carbon 14. In carbon, since atomic number is 6, 6 protons and 6 electrons will be there. And since atomic mass is 12 in carbon 12, 6 neutrons will be there. And in carbon 13, 7 neutrons will be there. In carbon 14, 8 neutrons will be there. Isotopes, part 3. Isotopes are classified into two types based on number of protons and neutrons in the nucleus. One is stable, another is unstable. Isotopes are stable when there is equal number of protons and neutrons in the nucleus. Isotopes are unstable when neutrons are more than protons in nucleus. It is spontaneous and natural. Then the extra neutrons tries to get out of nucleus of atom by forming different rays, as mentioned earlier. When they release different rays, atoms try to reach stable isotope configuration, thus losing neutron by way of three rays, alpha, beta and gamma rays, is called radioactive decaying of substances or atoms. Mostly elements where atomic number is more than 82 will have the tendency to release natural radiation when neutrons are more than proton and are unstable. Example, uranium, thorium, radium, etc. Alpha rays are less harmful when it is outside our body. It is less penetrating power. Small lengths up to 10 cm and can be stopped even by a paper. Beta rays are somewhat harmful and can be stopped by metals like aluminium. It is medium penetrating up to certain meters. Gamma rays cannot be stopped by paper or aluminium but can be stopped by lead and iron shield and is more harmful. It is most penetrating. Length of rays are more than alpha and beta rays. These rays can enter into air, body of creatures and even in any metal like rocks, etc. The substance which is disintegrated by spontaneous emission of radiation is called radioactive substance. This substance is called parent. The substance formed from this radioactive substance is called daughter substance. This is pictorial representation of three types of rays. Thanks for the clip. Isobars. Isobar is completely reverse of isotopes. For isotope, we are telling that atomic number is same, but atomic mass is different. But in isobar, atomic mass is same, but atomic number is different. If atomic number differs, then name of the element also changes. So naturally, different elements can represent isobar groups if they have same atomic mass. Example, sodium and magnesium, they have same atomic mass 23, but they got different atomic number 11 and 12. Likewise, argon, potassium, calcium, they have 18, 19, 20 as atomic numbers, but their atomic mass is 40 equally. Now we see how three rays behaves in magnetic and electric field. See the picture. The top picture is a magnetic field given. Two magnets are given in both sides and rays, radioactive rays are coming out, alpha, beta, gamma. Here, the alpha ray which is positive goes towards south pole, and beta ray goes towards north, and gamma ray goes straight without any deviation. Here, all alpha rays deviate less, but beta rays deviate more. And in electric field, we can see electricity is passed through and radioactive substance is passing in between that plus and minus signs of the electrical circuit. Here also, the alpha part, which is a positive one, goes towards, attracted towards negative pole, and beta, which is a minus negative sign, it goes towards a positive side of the electrical circuit, and gamma, it is no charge, so it goes straight. What will happen to nuclear structure when rays go out when neutrons are more than protons in nucleus? Radioactive substance which we use for getting ray is called parent. Daughter substance or atom is the one which comes out from parent atom along with emission of different rays and also with energy. Alpha ray emission represents helium. So when parent element gives out alpha ray, the dot element atomic mass is reduced by 4 and atomic number is reduced by 2 and one alpha ray is released. In case of beta rays, parent element lose one neutron. For that, against this, we get one proton plus and one electron minus in daughter cell, and also that electron is actually a beta ray. Gamma rays, no number is changing whether it's atomic or mass number. Only parent element is excited and daughter element is in ground state. Excited parent element is shown with asterisk sign. In this page, equation for alpha, beta and gamma rays given for easy understanding of the subject. Here, you observe that A denotes atomic mass, Z denotes atomic number. Here, for the elements parents and daughter and also rays are balanced. This atomic number as well as atomic mass are balanced. Using this, we have to frame the equations. Beta rays also same thing, and also gamma rays only there is no change in atomic or atomic number or atomic mass, but only we have to stay parent cell is excited and daughter atom is not excited, it's in ground state. For simplicity, we have given some equations for the understanding of the topic. Here, uranium is given. Uranium left side, the atomic mass is 238. Right side, it is giving out thorium plus helium. So thorium atomic mass is 234 and helium atomic mass is 4. So both side 238 to 238. And left side atomic number is 92 for uranium, and for thorium it is 90 and for helium it is 2. So both sides it is 92. So it is balanced. This tells about the theory of mass cannot be changed. Okay, neither energy can neither be created nor destroyed. In that same fashion, here atoms, the mass cannot be changed or reduced. It will be equal in both sides. Then we are given carbon, and which is emitting beta particle, carbon 14. So same way you can just see, and also gamma particles, only excited we are given how it has to be represented. The parent one is given asterisk mark, and right side nothing is given, same atomic number and the mass number, but there is no asterisk here, but it denotes that it is in a ground state plus gamma particle. Which instrument is used to count number of particles emitted from radioactive substance? We use Geiger-Miller tube. In short, it is called GM tube. Is used to measure count of particles emitted from substance. What are the dangers of radiation? The danger from alpha particle is very small until it enters the body. But beta and gamma rays may cause radiation burns on humans. Large costs of damages to our cells and tissue, or even mutation of genes or chromosomes, thus causing sickness, cancer, and even death to mankind and animals. It is due to these beta and gamma rays. If radioactive substances are not disposed safely by burying under deep depth with concrete and steel structures, but thrown open in open land and sea, it causes dangers to all creatures of the world. Properties of alpha, beta, gamma rays. First, we say nature of particle, charge on particle, mass, range, natural source of particle. Nature of particle, alpha rays are positive, beta negative and gamma no charge. And then here what's the number of charges? Alpha ray contains 2 plus charge, beta ray 1 minus charge, and gamma is no charge. Mass given, range, alpha ray is only 10 centimeter, very short, beta is few meters, and gamma is several meters. The natural source of particle, alpha rays mostly comes from atoms more than 82 atomic number, more than atomic number 82. Beta ray comes from Gopal type radioisotope, naturally it is coming. Gamma rays produced from excited nucleus. Uses of radioactivity rays. Alpha rays are used in smoke alarms to avoid disaster in homes and factories. Beta rays are used in to find the thickness of a paper or sheets in industries. Cobalt radioisotopes cures cancer. Cobalt radioisotope is nothing but beta rays. They can kill living cells affected by cancer but will go out of the body thereafter. Gamma rays are used in pasteurization of medical equipment, food preservation, and further, weak radioisotopes of different rays are used to work as tracer to find internal bleeding of blood and also the brain tumor. In archaeology, carbon-14 is used for carbon dating to find the age of animals like dinosaur. What is background radiation? Background radiation is the radioactive element that is present in air and air naturally and artificially. Natural background radiation. This come from sun, cosmic rays, though most of them absorbed by Earth atmosphere, some reach Earth's surface. Radon gas in the air. Some rocks like granite also emit radioactive radiation. Radioactive potassium 40 is present in many foods and we are eating it and it is absorbed by all creatures including human. Artificial radiation is emission from nuclear station. They are added to Earth as well as to atmosphere. Nuclear test using missiles also causing background radiation in the atmosphere. What is off-life period of radioactive elements? This is one of the important topic for students. When off of the radioactive atom undergoes decay process, the time needed for a quantity to reduce to half of its original value is the off-life. For example, the table it is given, first it is 100%, there is nothing decayed. And first off-life, it decays into half, 1 by 2. In percentage wise, it is 50%. In second off-life, it is going to 1 by 4th. That is 1 by 2 into 1 by 2, that is 1 by 4. Here 25%. In third off-life, it is 1 by 8, that is 1 by 2 divided by multiplied by 1 by 2, that is 1 by 8 and 12.5%. In 4 it goes like that, it go on dividing by 2. It goes right. 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16 like that. To find the life period of the old creatures, animals, we use decay curve. Decay curve is nothing but a curve having time in minutes in x-axis and activity in y-axis. Activity means it is decaying per second. The average number of decaying particles per second of sample is called activity. We can measure this emission of radioactive particle using GM tube at different times of interval. If we plot both activity in y and x-axis, we can get that decay curve. We can notice that the activity decreases by same fraction during equal time interval. In the decay curve, there are 3 off-life period in 30 minutes. Some solved examples in off-life radioactive elements. Problem 1. In this problem, mass of the radioactive sample is given and also it says, it's asking you what is it mass? What is mass after 2 off-lives? For this, we know already from the table we have seen earlier, for each off-life, 1 by 2, 1 by 2, it will go down like this. So for 2 off-life, it will go off into off, 1 by 2 into 1 by 2, that is 1 by 4. So 1 by 4 of the original mass. So original mass is 4 into 10 to the power of 18. So answer is, if we multiply this with 1 by 4, then we'll get 1 into 10 to the power of 18. That is the mass of the nuclei. Problem 2. This is giving off-life period for some sample is 15 minutes. In 1 hour, what is the fraction left? You know, in 1 hour, 60 minutes are there. So 4 off-life period it has undergone. So at the time, what will be the fraction? 1 into 4 into 1 into 4 into 1 into 4 into 1 into 4. That is 1 by 16. 4 times you have to multiply 1 by 4. 1 by 16. That is a fraction after 1 hour. Next problem, problem 3. In this, one experiment conducted to find the off-life period of radioactive iodine. The table is given. In x-axis, it is time per minute. That is 0 minute, 25 minutes, 50 minutes, 75 minutes. And count is 200, 100, 50 and 25. There is an y-axis. So question is, what is the off-life period of iodine? The off-life period is calculated based on time, and the time in which counts are equal. So here, after 20 minutes, 200 becomes 100. After another 25 minutes, 100 becomes 50. Another after 25 minutes, 50 becomes 25. So the off-life period, one off-life period is 25 minutes period. Then second question is, what is the fraction of original material is left after time period of 75 minutes? So in 75 minutes, there are 3 off-life period. For every 25 minutes, 1 off-life. So 25, then 50, then 75, 3 off-life period. So the fraction is 1 by 2 into 1 by 2 into 1 by 2. That is 1 by 8. Why carbon-14 is used for carbon dating? Carbon-14 is having longest off-life period, say nearly 5,700 years. It emits beta rays. As per Big Bang theory, carbon was present in the planets formed at the time. Most of the living creatures, including humans, are made from hydrocarbons. They developed carbon eating green leaves or plants which have carbon due to photosynthesis. It stays long in the skeletons of any creatures after death, but as years passes on, they lose some carbon due to off-life theory. Carbon-14, which is unstable, is attempting to become carbon-12, which is stable. Carbon dating theory works by comparing the amount of carbon-14 while alive in a sample to the amount of carbon-12 at present in dead body now. Because organisms stop taking in carbon-14 after death, the age of the material can be precisely determined by this ratio of carbon isotopes. Solid examples in off-life radioactive. This is problem number 4. Carbon-14 has off-life period of 5,700 years. Carbon is found in wood in all trees. Sample of wood 10 gram is cut down from a living tree, present living tree. It's an activity of 160 counts per minute using GM tube. One excavated charcoal of dead wood in the same region of 10 gram is found to have activity of 40 counts per minute. Estimate the age of dead wood charcoal. This is a question. Here we know carbon is used to find the age of the animal or any wood life structure. Here we are taking 2 for sample. One is live wood, another is old dead charcoal, dead wood charcoal, 2 of same quantity, 10 gram we are taking. And live tree now, it has got 160 counts per minute. And old dead wood charcoal, that is 10 gram, is 40 counts per minute. So from these 2 items, we can find out the life age of the wood charcoal. So you have to work out like this. After one half life, the living tree as charcoal will have 160 by 2, 80. After one half day, that now 160 it is counts per minute. That becomes off. That is 80 counts per minute after one life. Then second half life, it is 40 counts per minute. It becomes off of that. Since dead wood also having only 40 counts, so you should have two off life. You know, one off life represents 5,700 years. So for this two off life period, the age of wood charcoal, dead wood charcoal, will be 11,400 years. Thus, we have to find the age of the dead wood. What is nuclear fission? The world is facing energy shortage due to depletion of natural fossils like oil, coal, trees, all these things. So we don't like to destroy greenery also, green trees, which gives us oxygen to survive. So when we try to find out the alternative waves, then we found this nuclear fission and fusion, which can give extra energy which we require. But nuclear fusion is not possible to do in this earth, as huge temperature is needed for nuclear fusion. But nuclear fission is possible, in which heavy nucleus like uranium atom is bombarded with a low energy neutrons, which split the nucleus into two small nuclei. An abundant amount of energy is released in this process. It can be done in normal temperature, but within iron concrete chamber so that radiation does not go out. In all powerhouses of world, we use nuclear fission for power production, and in Japan it is more, as fossil fuels are very less in Japan. In the picture, it is shown uranium-235, uranium of mass 235 is bombarded with neutron. So both mass put together it is 236 uranium, which is unstable. It breaks into two, krypton and barium. Krypton having 92 and barium having 141. Put together total atomic mass is 233. So three left out mass was 3 neutron which are coming out from that process. This out of these two, if it is left alone, then it will create atomic bomb-like structure situation, as each one will again bombard with uranium and again 9 neutrons will be formed. Like that will go on. To avoid this, the extra 2 released, extra out of 3, extra 2 released are absorbed by control rods like boron or cadmium rods, which absorb the extra neutrons. So only one neutron will be allowed to collide again with another uranium, so that there will be control on nuclear reactor. If it is left uncontrolled, complete structure will blast, and heavy, just like atomic bomb situation will prevail, and human will suffer a lot. Example from my side also is given here. A is atomic mass, Z is atomic number, nuclear fission. Here, uranium 235, 92. So here, neutron is more than proton. So naturally it is unstable. Suppose if you send one neutron from outside and bombard that uranium, then it gets split into two. The atomic mass of barium of atomic mass of 141 and krypton atomic mass of 92. So, and a lot of energy is released. 3 neutrons are released, 2 plus 1 already. So 3 neutrons are released along with the energy. So here you can find mass remains constant along with 3 neutron. So barium krypton together it costs only 233 mass, but rest of the mass which is not shown here, it in the form of fission energy 3. So 1 is already present which we sent, and 2 are the new produced one. So from this energy is coming out. What is nuclear fission? Nuclear fission is a reaction that occurs when two or more atoms combine together to form to a single heavier nucleus. An enormous amount of energy is released in this process, much greater than the energy released during the nuclear fission reaction. So here we are using two substances, nuclear substances, to form fusion. By fusing them, we form unstable radioactive substance, and in turns it breaks into helium, and energy is we are getting it. Lot of energy is we are getting it along with daughter nuclei. So this energy from nuclear fusion is more than nuclear fission. So most of the countries prefer this. Nuclear fission and fusion. Stability curve. This stability curve helps to know how we defined lower limit and higher limit for atoms to become stable. Both nuclear fission and fusion are used to produce energy. If you observe the stability curve, where x-axis we have put atomic numbers and y-axis we have put stability of the atom, a curve is formed and is shown on the slide. As per that, up to atomic number 22, atoms are unstable, and from 82 onwards, atoms are unstable. So in between both 22 to 82, they are stable. So every atom wants to remain stable. So in nuclear fission, two small atoms of lower atomics are fused to form bigger atom, which will have more atomic number and energy is released. But in nuclear fusion, it requires very, very high temperature, which is not possible in this earth. No radioactivity rays like alpha, beta, gamma formed. Similarly, in atomic number more than 82, tries to break into smaller atoms so that it can stay stable. This is achieved by nuclear fission, and energy is all released here also. It can be done easily in normal temperature or room temperature using one neutron to bombard big radioactive substance like uranium. Alpha, beta, gamma rays are produced. Now we can see one-line answers in nuclear physics. 1. Choose correct answer. Man-made radioactivity is also known as induced radioactivity, spontaneous radioactivity, artificial radioactivity, 1 and 3 above. Here we see the question is man-made radioactivity. Man-made radioactivity is only induced and artificial. Spontaneous, automatically it is coming out, radioactivity is coming out from any substance. So that is not included. So induced and artificial radioactivity are the correct answer. 1 and 3 are the correct answer. In here, it is fourth number is the correct answer. What is the unit of radioactivity? This is Ranjan, Madame Curie, Becquerel, all the above. Answer is all the above. These are names of scientists. All the three, Ranjan, Madame Curie, actually Curie, Becquerel. Their names are used as units for radioactivity. Choose correct answer. In which of these no changes in mass number in daughter nuclei is noticed? Alpha, beta, gamma and neutron decay. Options: alpha ray, number 2 option is beta ray, 3 is gamma ray, 4th is 2 and 3, that is beta and gamma ray. The answer is 2 and 3, beta and gamma rays. There is no change in mass number in both gamma and beta ray. Which isotope is used for curing cancer? Option: radioiodine, radiocobalt, radiocarbon. Answer is radiocobalt. Gamma radiations are dangerous because it, number 1, affects eyes and bones. Number 2, affects tissues. Number 3, produces genetic disorder, produces enormous amount of heat. Number 4. Answer is number 3, which produces genetic disorder. It modifies the genes in our chromosome. So sometimes some persons will not have much organ, say hands or legs, something, or some cannot speak, like that. Many dangerous figurement. Which of the following statements are correct? Options. Number 1, alpha particles are photons. Number 2, penetration power of gamma rays are low. Number 3, ionization power of alpha rays are maximum than beta and gamma rays. Number 4, penetration power of gamma rays are high. Choice is option 1 and 2 are correct. That is A. B is option 2 and 3 are correct. C is option 4 is correct. D is option 3 and 4 are correct. Real answer is choice D. That is option 3 and 4 are correct. Alpha particles emit alpha rays and not photons. Choose correct answer. Proton-proton chain reaction is the example of number 1, nuclear fission. Number 2, nuclear fission. Number 3, alpha decay. Number 4, beta decay. Answer. Option 2 is the right one. Nuclear fusion. One nucleus of one substance of lower atomic number of fuses with another substance of lower atomic number. So proton to proton chain reaction comes here. It is happening mainly in sun side, in celestial bodies. The proton to proton chain, also commonly referred to as PP chain, is one of two known sets of nuclear fission reaction by which stars convert hydrogen to helium. Which of the following statements are correct? Option 1. Chain reaction is taking place in nuclear reactor and atomic bomb. Number 2. Chain reaction is nuclear reactor is controlled. Number 3. Chain reaction in nuclear reactor is not controlled. Number 4. No chain reaction is taking place in atomic bomb drop. Choice is A. 1 only correct. B. 1 and 2 are correct. C. 3 and 4 are correct. 4 is only correct. Answer is choice B. Option 1 and 2 are correct. Option 1 is chain reaction takes place in nuclear reactor and atomic bomb. Always is there chain reaction. One neutron is released and neutron is again bombarding with another nuclear substance, and again one neutron is released. Like that it is going on. In second reaction, chain reaction in nuclear reactor also controlled. It is controlled by using cadmium rods or boron rods, which absorb extra neutrons coming out. State whether the following statements are true or false. Number 1, plutonium-230 is a fissionable material. Yes, true. It is fissionable. Number 2, elements greater than atomic number 83 can do nuclear fusion. False. Only nuclear fission it can do, more than 83. Nuclear fusion is more dangerous than nuclear fission. True. Tremendous heat is required for nuclear fusion. It's not possible in the earth. Number 4, natural uranium-230 is used as nuclear reactor. False. Uranium-235 is used, not uranium-238. Then, if moderator is not present, then nuclear reactor will behave like atom bomb. False. Instead of moderator, you should have control rods like boron or cadmium rods, which absorbs the extra neutrons. Einstein theory of mass and energy produced will be equivalent is applied in nuclear fission fusion. True. Number 6, during nuclear fission, 2 or 3 neutrons are produced in energy. Yes, true. Match is their opposite. Uncontrolled fission reaction, controlled fission reaction, fertile material fusion reaction. Opposite side, breeder reactor, hydrogen bomb, nuclear reactor, atom bomb. For first one, uncontrolled fission reaction is the right answer is atom bomb. It is not controlled. Go on blasting, releasing more energy and energy. It will destroy the place just like Hiroshima, Nagasaki. Second one is controlled fission reaction is nuclear reactor. In nuclear reactor, fission is controlled by using boron rods. Fertile material is for breeder reactor. Hydrogen bomb is fusion reaction. Match each other opposite. Number 2. Cobalt 60, iodine 131, C14. Opposite side, thyroid disease, age of fossil, leukemia disease. Cobalt 60 is used to cure leukemia, which is skin disease, and also cancer it cures. Iodine 131 cures thyroid. C14 is helping to find out the fossil age. Arrange in ascending order of penetration power of rays, alpha, beta, gamma, and cosmic rays. Ascending order is cosmic rays, gamma rays, beta rays, alpha rays. Alpha rays are least. I request the viewers of this video to subscribe my video, share and view so that it will encourage me to release more such videos for children. Finally, one video link just I attached, it will be helpful for all. Okay, thank you. Jai Hind.